Anyone with any interest in astronomy may have heard of supermassive black holes. It has generally been thought that these black holes are quietly staying in the core of a large galaxy, simply eating the falling matter quietly. Hello, everyone. It was. However, recent research has shown that the issues surrounding these space monsters are not so simple. In fact, supermassive black holes may be wandering the universe, swallowing everything in their path. How can that happen? Everyone, this is the top ranking. Let's keep the channel as it is and take a closer look with us. Well then, we'll start. Space monster. Supermassive black holes are extremely heavy black holes. Even the lightest ones are hundreds of thousands of times larger than the Sun, and there seems to be no upper limit to their mass. The supermassive black hole in the center of the galaxy has more than 4 million times the mass of the Sun, but experts know that there are even more terrifying space monsters. It's not clear at this point how these monsters appeared. On the other hand, common stellar black holes are being elucidated, and it is known that a star with sufficient mass appears when a supernova explodes and its core collapses. But how much mass does a star need to collapse into a supermassive black hole? Although not an established theory, the most widely known theory is that supermassive black holes appeared in the early stages of galaxy formation. At this time, the supermassive black hole seemed to look like a huge gas mass with active star formation. At the center of the mass, the density of the substance is maximized, and the substance shrinks inward as it collapses due to its huge gravity. This typical model explains quite well why the currently known supermassive black holes are located in the galactic center. But some facts don't apply to that. For example, some relatively large galaxies show no signs of supermassive black holes in their nuclei. One example is the Triangulum galaxy, which is fairly close to the Milky Way and was previously featured on this channel. There are some theories that assume that the first black hole was formed by quantum fluctuations in the very early universe. I'm not going to give a lengthy and boring lecture on quantum physics here, but just keep in mind that this black hole emerged alone, so to speak, without going through a stellar explosion. In the universe at that time, matter existed more evenly than it does now. As a result, there were so many baits in this type of black hole. It is said that early black holes swallowed such substances and expanded, becoming thicker and supermassive. Recent studies seem to think that this theory is closer to reality. Wandering giant. There are regular collisions between galaxies in the universe. Our hometown, the Milky Way galaxy, also seems to have succeeded in swallowing some small galaxies. However, the one that always goes up. Billions of years later, our galaxy will also be swallowed by the Andromeda galaxy. A galaxy collision does not mean that a cosmic-scale cataclysm will occur. This is a fairly slow process that takes tens of billions of years, as large galaxies simply pull stars from the smaller sacrificed galaxies due to gravity. These stars change their orbits and begin to orbit around the galactic center, along with large galaxy stars. The distance between the stars is so wide that the stars do not collide with each other. But the supermassive black hole in the core of a colliding galaxy has an even more interesting fate. These black holes absorb large amounts of new matter, grow, and coalesce to create even more terrifying space monsters, but another theory has been proposed. What if the coalescence process is interrupted for some reason? It was. Or what if only a glaze of collisions occurred, resulting in the smaller galaxy wrapping around the larger galaxy? It was. In such cases, the supermassive black hole in the center of the sacrificing galaxy will wander alone in space forever. It is very difficult to notice these supermassive black holes. In fact, every black hole is defined as being relatively small in itself and emitting nothing. The supermassive black hole in the galactic core can be known by the abnormal movement of the surrounding stars and the generation of intense radiation from the accretion disk. Increase. Recently, researchers at the Harvard-Smithsonian Astrophysical Center have shown how many collisions are occurring in the universe, and how many single supermassive black holes are wandering in vast areas of the galaxy. The calculation was done. The result was stunning to the experts. The most conservative estimate is that there are as many as 12 of these wandering monsters in the Milky Way galaxy. All of these supermassive black holes are left by another galaxy that once swallowed part or all of the Milky Way galaxy. These black holes revolve around the galactic core, along with other celestial bodies that make up the Milky Way galaxy. If such a wonderful celestial body happens to appear near the solar system, we will not be safe. At best, its super-strong gravity causes a large number of trans-Neptunian objects to be ejected from orbit. Both the Earth and other planets will be exposed to heavy meteorite bombing. If you are unlucky, you may collide with a celestial body as large as Pluto or Charon. And the surface of the Earth will turn into a raging sea of lava. In the worst case, supermassive black holes can easily destroy the solar system. First, the Sun and all the planets will be forced to orbit the black hole and will eventually be swallowed. In this case, it will take longer for the Earth to be destroyed, but it cannot be avoided. After all, no matter which option you choose, it's not convenient for us. Has the mystery of dark matter been solved? But don't be afraid yet. Apparently, the supermassive black hole is not in the disk of the Milky Way galaxy, but in the area of halo. It is on the outskirts of the galaxy, forming a kind of shell. In other words, it is so far from the Earth that it will not pose any danger to us. In addition to the dreaded scenario of the Earth's destruction, this study also opens up other scientific possibilities. For example, this calculation shows that there were quite a few supermassive black holes in the early universe, about 2 billion years after the Big Bang. Moreover, there were far more wandering black holes than black holes in the galactic core that had just been created at that time. If somehow this calculation is actually supported, it will be very important evidence that the early black holes were created by naturally occurring quantum fluctuations. In other words, the formation of the galaxy is due to the supermassive black hole attracting a large amount of mass of matter around it, just like a ring dance. This is the end of today's video. Thank you everyone for watching. Perhaps, through this theme, we may be able to unravel one of the greatest mysteries of modern astronomy: what is dark matter? Dark matter is known to collect around galaxies and form massive halos. What if this halo was originally a supermassive black hole thrown out of a galactic disk and is now making its own mass? It was. If so, it would be understandable why dark matter interacts with other matter only by gravity. Everyone, thank you for subscribing to the channel and like it. Please turn on notifications and send us your comments. And don't forget to share this video with your friends on SNS. Thank you for your interest in this channel. See you again. Goodbye.